Okay, so the very first type of firewall we'd like to have a closer look at is the static packet filtering firewall, or SPF firewalls. And this type of firewall is probably the oldest and probably the most primitive or rudimentary type of firewall out there. So it has a lot of limitations, and we'll talk about those limitations one by one in the next slide. But probably the biggest limitation is the fact that the firewall looks at only one packet at a given time and in isolation. So it doesn't really care about how one packet is associated with others, as stated here. So when a packet is passing by, the firewall looks at it and then it just forgets and then takes a look at the next one. So it doesn't really have any memory basically, and it looks at one packet at a time in isolation, and it doesn't care how that particular packet is associated with the others. So what could be the disadvantage of doing something like that? Think about that. So what's being inspected? Static packet filtering, or SPF firewalls. So things being inspected. The main thing being inspected is, one of the main things being inspected is the IP addresses, and it's both source and destination IP addresses. So basically what this means is that the firewall looks at where the packet is coming from and where the packet is going, and it makes a decision on whether to accept or drop the packet based on the IP addresses. And the IP addresses typically belong to the network or internet layer of this OSI 7-layer architecture. If you're familiar with some of these basic networking concepts you learned from one of the networking courses you've taken. Another piece of information is port. So the port, as we discussed earlier in the definition section of the firewall in general, decides once the packet arrives at the destination host, it tells us where that packet is going in terms of the applications running on that particular destination host. But another thing you have to think about is also, it also shows the source port, meaning you can also tell by the port number, the source port number in this case, where the packet is coming from in terms of the applications running on the source host. So on the machine where the packet was sent, what application was actually sending that packet, we can also detect that kind of information. So in addition to knowing what application a packet is destined to, we can also find out which application actually sent that packet. The bottom line here is, this type of firewall, especially the SPF firewall, is simple and probably easy to use, but since it's not really looking at every single field of the packet header, in which you find things like source IP, destination IP, source port, destination port, that's all they look at. They don't really look at anything else. So you actually may miss some of these other important fields, the information contained in them, and those other fields are sometimes abused, but you cannot really detect that because you're not looking at that. So that's one of the limitations of the static packet filtering firewalls. And then, as we already discussed, since it's not really looking at the packets in association with the other packets, and it doesn't really have any memory, in that sense it's not really very intelligent, and you cannot really see the whole picture. I mean, how this packet is associated with others, and we cannot really look at that packet in the context of other packets, and that turns out to be one of the biggest basically limitations of this type of firewall. So here I'd like to give you a more concrete example of how SPF files are limited, because they're looking at only one packet at a time. In order for us to talk about the example, you have to understand what we mean by three-way handshaking first. Three-way handshaking is what's being done. Typically two hosts are communicating with each other, so before they send data back and forth, especially in a connection-oriented protocols, so-called connection-oriented protocols in networking, a host initiating a connection always sends this packet called SYN packet, and then the receiving side, if it wants to communicate with the sender of the SYN packet, it will send SYNAC packet, and then finally the original sender receives the SYNAC packet and then acknowledges the receipt of that SYNAC packet by sending its own ACK packet. So you may wonder why SYNAC from the receiver. In this case, that SYNAC packet serves two purposes. The first purpose is basically saying SYN, in this case meaning I want to talk to you too, and then it also acknowledges the receipt of the original SYN packet from the sender who initiated the whole communication. So after this three-way handshaking, finally the two sides are ready to exchange messages. Attackers often use this three-way handshaking to launch an attack. What I mean by that is, instead of actually responding to a SYN packet, which could be originating from the network under attack, it simply generates its own SYNAC packet without really getting contacted by the network under attack, and then it sends the SYNAC packet. So what happens at the SPF firewall is basically, let's say this is the network under attack, and let's say this is network trying to attack this network on the other side, and we have firewalls sitting in between. So we have a firewall here. So the role of the firewall is intercepting these messages going back and forth and drop any suspicious packets. So in this case, what happens is, without actually receiving the SYN packet, the malicious host sends this SYNAC packet to the host under attack, and the response of the host under attack will be simply resetting the whole connection, because this host never really sent a SYN packet, right? So that's why it will simply say, instead of saying ACK, because it knows it didn't send the SYN packet originally, it will simply say a reset RST packet. So what's significant here is the firewall doesn't know if it's a static packet filtering firewall. The firewall doesn't know whether there was a SYN packet from the network under attack originally or not, because it doesn't remember anything. The only thing it sees is basically the SYN packet coming from the attacker. So there's no way it can tell whether this is a response to an original SYN request here, or this is an attack packet simply generated by the attacker. So the firewall needs to just pass it on to the receiver in the network being attacked. So there's nothing it can do about this. So that's what shows the limitations of the static packet filtering firewall. What's wrong with sending a reset message to the other side, to the attacker? The problem here is by sending the packet to the attacker, basically you're letting the attacker know that there is a host on the other side that actually received your SYN packet. And when you send the SYN packet, of course you use an IP, so you know that the IP is actually associated with a real host, and there exists host in the network under attack with that IP address. So the bottom line here is now you identified a host inside a network under attack. So next time the hacker knows that there exists a host in the network it wants to attack with that particular IP, and it can take further actions. So despite these limitations, static packet filtering firewalls are still being used because for some purposes static packet filtering firewalls are still quite effective. So for example, your network receives a lot of ICMP messages or Internet Control Message Protocol messages, because one of the main mechanisms hackers are using to get more information about your network is by sending these ping probes or ping packets. So they send packets, especially ICMP packets, to see if anything in your network is responding to ping packets, and if there's a response, that means there's a host with that IP in your network. So the static packet filtering firewall can detect these ICMP messages and effectively drop all these ICMP messages, therefore reducing a lot of unnecessary network traffic. So another possibility is filtering the spoofed packets, or filtering packets with spoofed source IPs, meaning for attack purposes these hackers would change the source IP or replace the source IPs of a packet into something that's inside a network being attacked. So effectively what this does is, since source IP belongs to a host within your own network, another host in the network receiving that packet won't suspect or trust the packet with the spoofed internal IP address, source IP address. Another possibility is if you detect a packet with, again, a spoofed source IP that's going out of your network. In this case, the IP could be that of something existing outside your network. So from the perspective of your static packet filtering firewall, when it looks at that packet, it cannot have, for example, an external IP address because the packet was generated within your own network. So that's how it can detect these packets with spoofed source IPs, and they can effectively drop those packets with spoofed source IPs. So when you see a packet going out with an external IP from your internal network, it is possible that one of your hosts could be already infected and acting as some sort of a zombie computer, providing more resources to a hacker. Another use of the static packet filtering firewall is detecting malformed packets, and what we mean by malformed packets is a packet with configurations that don't make any sense, but these malformed packets can cause problems on the receiving side when the host is receiving your packet, and maybe even crash the host. So an example of a malformed packet could be something like its flags set up to both initiate and terminate a connection, a network connection between two hosts. So those are SYN flag and then reset flag. If those two flags are set up at the same time, what you're effectively saying is, I want to start the conversation, but I also want to stop the conversation at the same time, which is not making any sense. Therefore, this could cause some problems on the receiving side of the conversation.